Alright then, welcome back everyone. Let's solve this question, Valerii Against Everyone. I hope you have read the question once, but I'll again read it. So we are given an array B of length n, and we are defining another array A of length n again, such that AI is equals to 2 power Bi, where I goes from 1 to n, right? So if this is Bi, then AI is defined like this, that AI is equal to 2 power Bi, and this I goes from 1 to n. So you have n elements, that is. Now what this guy says is, every two non-intersecting or non-overlapping sub-arrays or sub-segments of A have different sum of elements. Right, that's what he's claiming. You want to determine if you can prove him wrong. So if this guy is saying that every two non-intersecting or non-overlapping segments of A, okay, this array, we are talking about this array, have different sum. To disprove him, you will have to find two non-overlapping segments or sub-arrays with equal sum, right? So more concretely, we are given this array Bi, and you can define AI based on it, like 2 power AI equals to 2 power Bi. And then you have to say, like, if there exists two non-intersecting subarray in A that have same sum, that is, you are disproving him, right? So in that case, print yes, otherwise print no, right? If you cannot disprove him, print no. So that's the question. So how do you approach this question? We know this, that the array size of B is n. Similarly, based on this B, AI is defined. So AI is 2 power B power I. Now if you look at the constraints of Bi, you see that Bi goes from 1 to 1 in 9. So the worst possible value of AI can be 2 power 1 in 9. Now this is a very big value. It's a massive value. You cannot store it in an integer, or guess not even long. So of course, this question says you in one way, there is no need to calculate this 2 power B power I. Okay, that's one hint for this question. Now what do we want to do actually? We want to prove him wrong. So how can we prove him wrong? We are looking for two segments, right? Not just any two segments, two non-overlapping, right? This is a very important word here, non-overlapping, right? So no two elements, like not a single element can match between these two segments. So we are looking for two non-overlapping segments, L1 R1 and L2 R2. Okay, we are looking for these two segments, L1 R1, L2 R2 of A. Of course, these segments are defined on this array A with same sum, right? So we are looking for this. We're looking for two non-overlapping segments with same sum on this array. You know, for the fact you cannot calculate these values, because that's just not going to work out. We cannot store this value. But what do you know about AI here? Of course, you cannot calculate AI, but you know for the fact that AI is a power of 2. Now, if it is a power of 2, binary numbers should directly ring something in your head, because if you represent a number which is a power of 2 in binary, what is it? It's just one bit set, right? It's just one bit set and the rest of the bit 0, right? Because 2 is what? 1 0, 4 is what? 1 0 0, 8 is what? 1 0 0 0. So if AI is a power of 2, you will only have one bit set, right, corresponding to that power. Okay, so that's a good observation. So what I'm trying to say here is, this AI is a power of 2. Okay, so what will happen is, in the binary representation of the AI, you will only have one bit set. In other words, let's just say these are the weights, 2 power k, 2 power k minus 1, so on, 3, 2, or sorry, 2 power 3, 2 power 2, 2 power 1, 2 power 0, right? So what can happen is, for one of the guys, only this bit is set, right? For one of the guys, there's some bit here which is set. For some guy here, only this bit is set. For some guy here, again the same bit is set, right? Basically what I'm trying to say is, the AI is distributed like this, right? So some, like, one bit will be set randomly for this range. So this range, like, it doesn't really matter, but only one bit will be set. That is my point. Now what are we after? We are after two non-overlapping segments with the same sum. Now looking here, one thing is obvious. If you have two guys with the same bit set, you have got your two non-overlapping segments, right? So I don't know what this value will be, but here one segment will be this L1 R1, and another segment will be this L2 R2. So if you want to index it, let's say this first index guy, this is second index guy, this is third index, so this one, and this is fourth index guy. So what you can do is, L1 R1 is actually equal to 2, and L2 R2 is actually equal to 4. In other words, what I'm trying to say here is, if you have two guys with the same bit set, you've actually got your two non-overlapping segments with the same sum, right? That is to say, if any two guys have same bit set, In other words, for any two guys, bi is equals to bj, that is, this ai will be equal to aj, right? So for any two guys which are same, you can get a segment, right? So if you have any two guys which are same in this array or in the b array, you can disprove him, right? So you can print yes. But what if you don't have any two guys which are same? So all the guys are unique. All the guys are unique in your array. And in that case, what will happen is you will have bits at distinct positions. You will have something like this. No two will have the same bit set. So I'm just assuming this is one of the combination, right? So no two guys are having the same bit set. Now you choose any two non-overlapping segments. Let's say this, then this. Non-overlapping is very important. You choose any two non-overlapping segments here. They will have different combination of set bits, right? When you sum them up. If you sum all the elements here, what is the final answer? Final answer will be one here, and one here. If you sum these two guys, your final answer will have one here and one here, right? You choose any two non-overlapping segments here, you will always get a unique combination of set bits. You will always get a unique combination of set bits. So in this case, you will never be able to disprove him, right? So you cannot find an example here where two segments have same sum. So what it proves is, if you have all the elements of B to be unique, this will ensure all the elements of A will be unique, okay? And in that case, you can never find two non-overlapping segments with the same sum. For very simple reason, any two non-overlapping segments you choose will have different combination of set bits. So to have two non-overlapping segments with same set bits, you need at least two guys to be same, right? So there has to be one guy here which matches with one of them. If you have more than two guys to be same, it's very good. There is no problem here. But you need definitely two guys to share the same bit, right? To share the same bit position. In that case, you have got your segments. So yeah, that's that about the question. So here's the code. The code is pretty simple. In the end, what you want to effectively check is whether you have two elements, that are same. In other words, you have to check whether your array contains only unique elements. Which array? Your B array, right? Because if B array contains unique elements, you'll definitely have all the unique elements in A array as well. So there is no need actually to compute AI values, right? So what I did is, I did it very simply. I inserted all the values of B array into a set. And if all the guys are unique, of course, the set size will be equal to n. So in that case, you won't be able to disprove him. So you will print no. But if it is not the case, you have at least two guys to be same, right? If the set size won't be equal to n, then it will be print yes, right? So yeah, that's about this question. I hope you got something out of this video. I'll see you in the next one.